The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Alright, for number 5 of the bonus problem, we're given a series and we need to find a formula for the nth partial sum. So this problem is relatively difficult here, or at least it is to be able to tell what you need to do. So we have our sum of 4 over n times n plus 2. So what we need to do here is figure out how to get a representation for the nth partial sum. So remember, the nth partial sum represents the sum of all the terms up to that n. Now, if this was just an n or n squared, you have formulas for that are easy to derive, or possibly even something you've memorized before. However, when you have them in the denominator like this, there really isn't a formula to follow. Your best bet in these types of situations is doing it by partial fraction decomposition and hoping that it works out as a telescoping series. So I'll do that here to show you what I mean. So what we want to do is decompose this into two fractions. We have two very basic linear terms, so the actual partial fraction decomposition is not going to be very difficult here. We know that a over n plus b over n plus 2 would have to be our series function, 4 over n times n plus 2. So we just need to figure out what the a and b are. This is a simple partial fraction, so we get a times n plus 2 plus b times n has to equal 4. The numerators, once you get everything to have a common denominator. You can see here that you have an a n plus b n. You don't end up with any n's in the numerator, so those definitely have to cancel out. The only way that you could possibly get a constant here is a times this 2. That has to equal 4, so thus you get a equals 2. If you prefer, actually let me write that group so it's easier to see. an plus bn, you want to write instead as a plus bn, and then you have plus 2a. So you can see here that this term right here should be 0 because you don't have any n's over here. But this term right here must mean that a equals 2, and then if this term has to be 0, if a is 2, that means b has to be negative 2. So therefore, your partial fraction decomposition, so this sum can be equivalently written, instead of 4 over n times n plus 2, we can write it as 2 over n minus, because then we got a negative 2 for b, minus 2 over n plus 2. So this is actually going to work out as a telescoping series fairly easily. Remember that a telescoping series means that if you sum up these two terms, so we're going to put these two plus their next two plus their next two, eventually positive and negative terms are going to be canceling out throughout the entire list. That's what is the hallmark of a telescoping series. Now, because our two terms are off by n plus 2 to n instead of being n plus 1 to n like in a typical telescoping series, that means the terms that cancel out are going to be two terms apart in the series instead of one term apart. So let's start writing some out so you can see that. First, we'll try when n equals 1. Our first term in this series is 2 minus 2 over 1 plus 2, so we get 2 minus 2/3. So in a normal telescoping series, the next term would have something that would cancel out with the first one. We're not going to get that because our telescoping series is, you can think of it as it's spaced by 2. So our next term is when n equals 2. When n equals 2, we get 1 minus 2 over 4, 1/2. You can see so far nothing has canceled out, and that's to be expected. The next term we should get something to cancel out. So that's when n equals 3, we get 2/3 minus 2/5. So you can see here we got a negative 2/3, we got a plus 2/3. That's going to cancel out. And I'll just do one more to show you what that's going to look like. When n equals 4, we're going to get positive plus 1/2 minus, that's going to be 2 over 6, which is 1/3. You get minus 1/2 plus 1/2. So what we need to consider is what terms are actually going to be left once we add, tons of terms of this sequence. Well, the first two of the first, let me actually write some parentheses around these so I can say this more clearly. Of the first two terms of the series, the first parts of them are never going to cancel out with anything else for the rest of the term. Usually, like I said, in a telescoping series where you're only one off, the very first one would never cancel out, but everything else would. In this case, because we're two spaced, the first two halves of the first two terms are going to stay there. Everything else is going to cancel out. So let's think about, now on down the line, the last two we need to write in terms of some letter, let's call it K. Actually, the problem says the nth partial sum, so I guess I'll just write it in terms of n, although you usually want to avoid the variable you already used. So the second to last term would be 2 over n minus 1 minus 2 over n plus 1. N plus 1 because it's n minus 1 plus 2. And then the very last term would be this, 2 over n minus 2 over n plus 2. So now what we need to consider is what would be left at the end. Well, if the first two, in the first two terms, the first pieces were left, in the last two terms, the last two pieces will be left. You can think about it like this. If the last piece here is n plus 2, n plus 1, you can think the term before this would have been n. It would have canceled out with this one. So this is going to go, and we're going to have the last two pieces. The last two pieces of the last two terms, and the first pieces of the first two terms. So the nth partial sum is given by what's left after all of that. Well, we have 2 plus 1, so we have 3. We have a minus a 2 over n plus 1, and we have minus a 2 over n plus 2. So the first two terms were just nice, easy numbers, so we put them together as 3, but the last two are dependent on n. So what is something that, if this was not on a timed quiz or exam, that you could do to show yourself that this works is try 1 and 2 and 3 for n, and you should get the actual sums when you plug in 1 and 2 and 3, and those are easy to verify. So that's part A here, and write that. Finding the formula for the nth partial sum. We have this formula right there. You wouldn't need to do common denominator and all that. You could leave it like that. So the last thing is to find the sum of the series. Well, the sum of the series is the limit as n goes to infinity of the nth partial sum of 3 minus 2 over n plus 1 minus 2 over n plus 2. If this is the sum for any particular n, if we want the sum of the whole series, we want n to be infinity. Well, in this case, that's pretty simple because we have 2 over infinity, 2 over infinity. Those things are just going to be 0. So we get that the sum of this series is just the number 3.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.